This is just a short video to talk about what a short circuit is and an open circuit is and what they mean, as we'll be coming across them fairly commonly in our more complicated circuits. So the idea of a short circuit, if you think about your typical resistor source circuit here, if your R was going to 0 here, so you have a resistance of 0 ohms, that's a short circuit. Short circuit is when R is equal to 0. And what does that mean here? Well, you have your V equal to I times R. So if your R is 0 here, that means your V is 0. And so what's going to end up happening is your voltage across your short is always going to be 0 volts. So a short circuit always has no voltage across it. However, it will have a current through it in general. Now, I do want to point out something here, that this particular circuit I drew is actually no good anymore with a short circuit there, because those things are supposed to be in parallel, and parallel things are supposed to have the same voltage. So if you have something like a 9-volt battery here and you have this short over here, mathematically that's not possible. And realistically, please don't do this, but if you short out an actual battery, you can cause damage, maybe a fire, things like this. So again, just showing you a little bit of differences. Mathematically, we can't have a short on a battery, right? 0 is not equal to 9. But physically, if you do short a battery, it can, obviously it can happen. You can put a wire between the two ends, but because everything kind of breaks down there, you're going to have too high of a current, it's going to overload the battery and cause it to, like I said, melt, start on fire, or something like that. If you really want to see that, go look on YouTube. You can find some good videos of people short out batteries and how dangerous it can get. With that said, an open circuit is pretty much the exact opposite of this scenario, where instead of your R going to 0, your R is going to go to an infinite ohms. Now normally what we then do is we then cross this out and we'd write it like this here, and that is what's going to be an open circuit. So open circuit is when your R is going to infinity here. Now in that case, if you solve for the current in your Ohm's law and you let your R go to infinity, this is going to go to 0. So for open circuits, you are always going to have 0 current through them. And again, that makes sense. If it's open, it's not connected, you can't have any current flowing through there. And unlike the short circuit case, you can mathematically have no problem with this diagram with a battery with an open circuit on it. And that's literally just a battery that hasn't been connected to anything yet. That's an open circuit there. Now I will say that even when you have an open circuit, right, things are not quite perfect. It's not actually infinite. Right, there is actually a resistance to that gap in the air, and you can actually have current going through there if you have a high enough voltage, and you actually see that in the form of lightning in the real world. So again, we are dealing in this class in the ideal mathematical models for these problems, but it is also good to at least be thinking in the back of your mind about real life and how that might change what we're doing in this class. But the important thing is, short circuits are like resistance 0, they have 0 voltage. Open circuits are like resistance infinity, and they have 0 current. Right? Again, one's 0 voltage, the other is 0 current.